This is the ATG webinar series from our civil team. The topic today is generating sheets in Civil 3D. My name is Brian Tanner. I'm a senior technical specialist for our civil development team here at ATG USA. Today is April Fool's Day, but I'm trying not to fool you, and hopefully my computer and the technology that I depend on is not going to fool me today either. Let's see here. Move on. Again, Brian Tanner. Senior Civil Technical Specialist. I'm from Mishawaka, Indiana, and while I'm not trying to play any April Fool's jokes on you, Mother Nature has played an April Fool's joke on me. It is currently snowing outside, and I am not a fan. I thought we were past that, and surely we're not quite yet. But I'm a Civil 3D certified professional, Autodesk certified instructor, Green Road Sustainable Transportation professional, and a longtime contributor to the Autodesk User Group International magazine. A couple products that I specialize in and perform some consulting with ATG and some of the services that we provide from our team. I'm one of 12 professionals on our civil team that provides a high level of expertise, and our collective experience is put to use for you when you work with us. Today, we're going to talk about generating sheets, and the general consensus out of Civil 3D, out of the box, is that we are dependent on Viewframe Groups to produce those sheets. Now, specifically today, we're going to be talking about linear sheet production. Certainly when we work on site projects, whenever we work on more expansive area projects, we have a slightly different approach that we have to take because it's not a linear project. We are tiling sheets out on a grid typically. And there are some great tools for that out of Civil 3D because of the fact that it's built on top of Map 3D. We can utilize the Map Book tool from there. But we're not going to specifically cover that today. Maybe join us for a future endeavor. Leave a comment in the chat or in the Q&A if that's something that interests you. And maybe we'll provide a specific webinar topic on that in the future. But today we're going to be talking about linear sheet production using the out-of-the-box tools and then possibly another quicker, better approach to producing sheets inside of Civil 3D. So Viewframe Groups are what we are dependent on in Civil 3D, and we are going to get into a quick demonstration for this from a beginner level, but also using some more advanced tools for those who are coming from different levels of experience going into Civil 3D and producing these sheets. But we're dependent on Viewframe Groups to cut those sheets out of the box in Civil 3D. The Viewframe Groups themselves are based on alignment information. Again, it's linear information. And we also produce profile views and viewports based off of template information along those linear projects. Whenever you choose to create sheets that contain a profile view, we also do have to have a profile in our drawing. We can't just create profile views off of no data. So we've got to have alignment information for our plan view information, and we have to have profile data in order to create a plan and profile sheet. Now, that's not what we're limited to. We can actually cut plan sheets, profile sheets with those stacked views on top of each other, or overall plan sheets that take up an entire page. We just have to have a different template with a different type of viewport that is dependency on all those things. Thanks for the comment, Barry, for tiling sheets with large subdivision projects. The more comments we get back like that, the more likely it is that we're going to produce a webinar like this in the future. So thanks for the feedback. When creating sheets from those Viewframe Groups, so the Viewframe Groups define the area in which we are cutting sheets and the representation of what is going to be included in a viewport. But when we cut those sheets, we're not manually deriving those sheets. We're not manually creating a new drawing file with a layout view and multiple viewports and manually aligning and rotating everything in that. Fortunately, the out-of-the-box tools give us the power to use the information that's at our hands, the viewport, the scale, the physical dimensions of it versus the scale of our model drawing and the contents within there to derive the sheets to be cut based off of that information. The view frames are rectangular areas. It's nothing more special than that. It's just if we have a rectangular viewport in our template drawing that we're basing these sheets to be cut from, that's the exact shape of our viewport that's going to be created in the view frames that are going to be associated to our model drawing. The automation saves us from making those manual changes that I mentioned before, except for one little thing, and we're gonna get into that. The sheets are static. So once you develop a sheet from a view frame group, there is no inherent relationship between the drawing that's been created, the layout and the viewports that have been created to the view frame itself. You can make changes to the view frame as much as you want, but it's not going to automatically change what's been produced in your layout. To update those sheets with these out-of-the-box tools, if we're going to manipulate the view frames and maybe the entire view frame group, we must repeat the process of cutting those sheets. And while that may still be quicker than doing it manually, we also have to acknowledge the fact that we may have done additional work in those sheets that is then lost if we have to recut those sheets. It's not necessarily the end of the world, but rework is the death of our profitability on projects as consultants with our clients. So we either have to manually make those changes to the individual layouts and the individual viewports so that we save all the changes that we've made in those sheets, or we have to wipe out whatever progress that we've had and recut the sheets using the out-of-the-box tools from Civil 3D. It's just inherent to the programming of Civil 3D. The thought process was and remains to be for the programming of Civil 3D that the last thing you do on a project is cut sheets. The reality, though, of how we work on projects is we have to cut those sheets earlier on in a project for the deliverables. We have a 30% submittal. We have to have sheets representing what the work that we've done thus far. And between that 30% and 60% or 30% and 90% or final approval, there may have been changes that required us to change the layouts. And not just the kind of information that we've labeled, but the extent of the views, the stationing ranges, the overall limits of the project. And those are the kinds of changes from early on toward the end of the project that the out-of-the-box tools just don't fully accommodate. They're great for what they're used for and what they were intended for, but it is a limitation. So let's talk about a quick demonstration utilizing those tools. And we'll jump over into Civil 3D with an example data set that I have. Not a very long alignment, admittedly. The power of the layout tools of the view frame groups and the create sheets tools is really whenever you have long linear projects. The more layouts that are created, the more sheets that are generated, the larger the benefit of using this tool set is. Because it's just exponentially more time that you've saved compared to creating the sheets manually. Admittedly, this is a fairly small data set. We're really only going to create I believe 3 view frames and 3 sheets ultimately out of this, but the concept remains the same. I just wanted to have something workable, manageable, that we didn't have to wait more than a few seconds for the sheet views to be generated and then for the individual drawings to be generated while we go through this webinar. So the first thing that we have to confirm when creating views is that we have the correct information available in the drawing. We have to A, have an alignment that the view frame groups can be stationed off of. B, have profile data that we can cut profile views off of. Again, that's if you're doing a plan and profile sheet, which is pretty typical. But if it's just a plan stripped sheet, then that's the only information that we have to have. Now, we have the correct data in this drawing that we are dependent on for cutting our view frames and then ultimately creating our sheets from. But there's also an additional piece of data that we're reliant on that in this example is in this drawing, but really it just needs to be a part of a template somewhere on your server. And that is an example layout that represents the size of viewports, orientation of viewports, and scale of viewports that Civil 3D is going to query in order to determine the size of the view frames and their orientation in our model. I'm just going to use this file as that template. Generally speaking, you're going to have a model template that you use for Civil 3D and likely another template that you use that contains all the variety of layouts that you require. Right now, I've just got an ANSI D-size sheet that is a plan and profile sheet, and you'll see that I've got a viewport for my plan. It is set to a 20-foot scale. I'm representing that accurately within my layout names, so whenever I pick on it through the dialogues, it makes it dead simple to make sure I've got the correct layout selected and everything's set up the way I need it to be. But one of the key differences for Civil 3D viewports compared to our traditional AutoCAD viewports is that they have a named type. So selecting the plan viewport, if I go to properties, I have to make sure that the viewport type is set to plan. You can see that there are undefined plan, profile, and section viewport types. Same thing for my profile viewport. Yes, I need to make sure that it's at the correct scale. The dimensions are important, left to right, up and down, based on the size of profiles I intend to fit at a 20-foot scale inside this viewport. But again, it needs to have a viewport type defined as a profile. That's the information that Civil 3D is going to read while going through the viewport or the viewframe creation that determines which layout contains the right formatting to accommodate a plan and profile sheet to be created. So oftentimes, if we work sometimes in an ANSI D and architectural D, or maybe even architectural E drawing, we would have to have 3 different layouts, one for each sheet size. In addition to that, we would need to have layouts representing each of the scales that we typically work in. So if we do some work at 20 scale, some work at 30 scale, some work at 50 scale, we would need to have additional layouts for each of those scales represented, because again, the viewport needs to have the type saved to it, but it also needs to represent the actual scale that we want to produce these drawings at. That's what Civil 3D depends on. It is measuring against the physical dimensions of the viewport itself in conjunction with the actual scale of the viewport for what can fit inside of it. So this is a very simplistic approach to it, but a typical template that represents all those layouts for Civil 3D, you may have 12, maybe even 16 sample layouts that represent all of the various scales, all the various sheet sizes, and maybe even purposes. Maybe you have a plan profile style, maybe you have a plan, maybe you have a profile or an overall plan type sheet. And then there's the other side of it where we need to have cross-section template views set up as well. But we have what we need in this drawing with a simple viewport representing plan and profile. So we have everything that we need to move forward with our sheet creation. We've got a template to work off of. Yes, it's in our current drawing, but that's okay. We could always format and select that appropriate drawing through our process internally, off of a file saved on a server or through our Autodesk Construction Cloud and desktop connector, wherever we have that file saved. So the first thing that we have to do is define our view frames and determine where those view frames are ultimately going to be placed and their orientation. So we will go to the Output tab, Create View Frames. And I'm going to go through this fairly quickly. I don't want to take an hour just talking about the Civil 3D out-of-the-box options. I'm going to presume that there's some level of understanding here and that this isn't a full training session. So bear with me. I'm going to go fairly quickly, a little bit faster than what I would definitely do during a full-blown training. But I'm going to choose my alignment, define my station range, choose that I'm using a plan and profile style, make sure that I am jumping out to whatever my template file is that represents that has the layout information that I'm dependent on. That's my current drawing, and it's going to find that layout view that has the correct scale. I'm going to rotate my views according to the alignment, and I'm always a big fan of leaving some extra space at the beginning of each page to allow for labeling between each viewport, especially at the beginning of the project where you don't have options for overlap. The viewframe group name, I would normally take a little bit of time to label that, but really don't spend a whole lot of time here. It just needs to be a decent style that doesn't busy up your drawing too much to where you start to lose track of where everything's at. And the viewframe group name might relate to how you're going to label the viewframe group whenever the actual sheet set is produced. Positioning, I like to always snap things to an even station, at least what my major station increment is. If I want to have some overlap in between each sheet in my set, I can allow for some buffer space in between those sheets so I don't have to necessarily flip my page to gain context of what came right before that sheet or right after the sheet. Define my match line style, that's literally the line that's cutting through the sheet itself. Defining the match line from the previous or successing sheet, and then the associated label styles for those match lines. Again, not going to go into this in depth. It's just the process more than the styles. What's the current view style for my profile view that I want to use? Make sure that it is a style that works for the actual sheet scale that you're going to be producing. You may have designed your entire profile at 1 to 50 scale using a different data band because that contains the information that you needed for designing it. That doesn't necessarily relate to the style that you need to use on your sheets that are going to be produced for plan production and ultimately for printing and presentation to your client. So make sure you select the correct view style for the profile view and the data band. I'll adjust that really quick and create my view frames. Pretty simple, straightforward process. Went through it fairly quickly, but each of these view frames represents a 20 scale sheet given the viewport size that I have in the example layout and what can fit on there. Now, I mentioned before that the sheets that are created ultimately from these view frame groups are static. That is true, but whenever we first create the view frame group, before we cut our sheets, we can make adjustments to the view frames themselves. If you need to rotate, if you need to change the actual physical orientation, if you want to change your stationing range, we do have the diamond grips to change our station range, the square grip to fully realign and reposition the view altogether, and this circular grip that allows us to rotate our view's alignment. Remember, we chose the option to orient our views to whatever our alignment was, meaning north is basically irrelevant. It's going to position north wherever it needs to rotationally within the viewport. And if we wanted to be a little bit more refined rather than averaging out the position of the alignment, we could rotate and reposition these views. Just make sure when you do it, you also rotate and reposition your match lines so that it conforms to wherever your sheets are actually intersecting between each other. Fairly straightforward. We could obviously get deep into the weeds as far as the styling goes for that process, but let's create our sheets now. Taking a little bit longer than it normally does, but we've got the one view frame group in this drawing. I can determine if I'm going to create sheets for all view frames as part of this view frame group. We've only got 3 here, but technically if you needed to break it up further, you could choose fewer view frames than what you produced for that given alignment. Are we producing a new layout in a new drawing, or are all new layouts going to go into a singular drawing for that alignment? Again, because the view frames are produced by alignment, so are the sheets that are produced. They're going to be producing a new drawing per alignment or placing all of those those new layouts and new sheets in my current drawing. I'm personally a big fan of the sheet set manager, use it extensively for updating my title block information, publishing my sets and things of that nature. Also allowing people to jump into a project at the 11th hour when more than one person needs to finish a project up. So I do produce a new DWG file for each sheet. We do have a north arrow block that we can leverage in those sheets. So whatever the rotation of our viewport is, the north arrow block is going to be inserted and rotated to that orientation of the view. Next, I do have a sheet set already that I predefined as part of the training just to speed things up a little bit. And I'm going to make sure that it's saving the new sheets to that sheet set, and the new drawing file that's being created are actually new drawing files, plural, because I'm creating a new DWG for each layout to be cut. I can go in and I have a personal preference for naming the files based on my project naming structure or our CAD standards naming structure, to where maybe it's a 2021-04-01 project. I'm just going to use today's date, ATG TP next counter. And it's going to label each drawing file PPO1, PPO2, PPO3 along that same structure within this file location. Again, that's probably going to be a project folder structure under a DWG subfolder, however and wherever you typically save those production drawing files. Next, make sure that we don't have any weird settings within our profile view configuration. I know every once in a while somebody will go through these steps and split profile view will be checked, and it throws everything off as far as the datum shifts that occur across the entire length of the profiles to be created. but we'll just use the profile view settings from the profile view that happens to already be in this drawing. And I tend to like to center my plan and profile views based on the middle station within those station ranges. It just ensures that across more of the plan and profile view, we're more in line with where things are, depending on how curvaceous an alignment is, because we can certainly fit more of a horizontal curve alignment in a drawing than we could fit a profile. The stationing for a profile will not change based on how curvy an alignment is. So we can always fit more of an alignment on a sheet than we can of a profile. So go to next, and then develop that data shortcut and data reference relationship between the objects that are in this drawing versus the objects that are going to be developed in the sheets that are ultimately created. I'm just going to choose the top surface. It's going to automatically bring in the alignment because it's dependent on the alignment that we're cutting these sheets in the Viewframe group off of. And it's also going to automatically create a data reference for the profile data that's being brought into those sheets as well. If you have pipe networks, if you have pressure pipe networks, if you have site specific information, we can automatically create those data references as well. But we'll go ahead and create sheets. It'll save our current drawing. I have to define where the profile views are going to be generated in each of those sheets that are ultimately created. That's going to just be a point out in space away from the rest of my geometry. I don't want those new profile views that are cut and spliced into 3 different views to overlap with any of that geometry on those sheets that are ultimately created. Mind you, I recognize that these sheets that are going to be created are not going to be perfectly pretty. This is an example data set, and it's not fully tweaked to what I would see in a production set. But the process is done. My drawing's saved based off of those changes. It's going to create plan view information based on our Viewframe group locations and orientation, and it's going to subsequently cut multiple profile views, one for each sheet, based on those same station ranges. And it's going to be part of my sheet set manager that I pointed it to associate those drawings to. So if I hover over sheet 4, 5, and 6, we're going to see a quick preview that those sheets were created. I can look down at the file name and location to determine that it did in fact create those sheets that I just named on a per drawing basis at the location I defined, and it did it at, basically currently. These are new drawings that within the last minute and a half have been created. So if I double click on that sheet layout, again, let's not judge the style here too much. And certainly I've got a line type in this file that needs to be cleaned up based on the SHX file warning that I just got. But one of the things that is a little bit wonky is my elevation range. Probably one of the profile settings that I jumped through and didn't define in detail when creating this sheet. That's on me. I just used the default settings for the previous profile view that we based it off of, and clearly there looks like there needs to be about a 20-foot shift in what we're actually seeing within the profile view range. A little change there in a region of my views, and it's a little bit closer to what I would expect to see on a set of drawings. I could continue to go through the subsequent sheets, but I think you can get an idea of what's ultimately being produced here. Is it perfect? No. Did it produce what it produced fairly quickly? Yes. The biggest problem that I have, and most users have, is what I described before we came into the demonstration. It's that static nature of it. If I move that viewport, and we're starting, the alignment actually starts here on the southern end of the project. If I move this viewport, change the orientation, change the station range, whatever the case may be, there is no relationship between that and the sheets that are actually cut. There's nothing that's going to even prompt me that anything has been changed. Is that a problem? It depends on what your approach and what your workflow is with Civil 3D. If you're at the beginning phase of a project and you're just cutting these sheets for the first time and you haven't done any additional work, then maybe it's not an issue. Maybe it's easy enough to go back into your model drawing, make those rotation and positioning changes and recut those sheets fairly quickly. If our feature settings and our command settings are defined properly in Civil 3D and we don't have many changes to actually make and adjust from our dialog boxes, then we can run through this process in a matter of a few minutes. And it's really not detrimental to our productivity. but it's whenever we're at the 11th hour of a project and we need to make some changes, or we're at that 60% submittal range, and the sheets that we initially cut just don't capture everything that we want, that we start to run into some problems. So really quick, back to our presentation slides. Sim Project Suite is a tool set that, for those who've been following ATG for any length of time, knows that we're a big fan of. We're the sole distributor of in the United States for the Sim Project Suite from CTC Tools. It does come to the rescue under these circumstances. The Sheet Generator tool set provides a workflow which allows us to make changes, allows us to accommodate updates to our project further down the line without losing that additional work. We don't have to completely recreate our sheets. We can just update changes to view shapes rather than view frames that come right out of the box from Civil 3D. So it's a similar process. The dialog boxes look a little bit different because they're generated by CTC, and it's going to be formatted a little bit differently. The options that we're going to choose are going to be named slightly different, but it's actually pretty interesting. We use a dialog box that's almost identical whenever it comes to setting up our profile view frames, but we have much more control. And an added benefit is we don't have to create as many templates or template layouts using the Sim Project Suite and the Sheet Generator. We control our viewport scales through this tool rather than having to have a different layout template for every single scale that we intend to use on projects. So we can save ourselves some setup and some maintenance of our projects over the lifespan of our CAD management by using the Sim Manager Suite. Let's jump back into Civil 3D really quickly. I'm going to go ahead and delete my view frames. And that was not intended, but there we go. We're back into Civil 3D again. And I can use, again, the Sim Project Suite to go through a similar process. I'll admit right up front, the first time you use this, especially if you've been using the Create View Frames and Create Sheet tools for years, it may seem a little foreign. I guarantee the first time that you used Viewframe Groups and Create Sheets, that seemed pretty foreign too. So I hope you keep an open mind and understand what options we have available to us and how much more strongly this allows us the flexibility to work the way we need to work inside of the software. All right. So again, actually two little setup things that we do need to have to use the view shapes is, rather than just a viewport in our sheet. So I've kind of set this up to work for the webinar. I'm not trying to cheat anything, but I did do one little step ahead of time. I don't just have a viewport here. I do have additionally a block that represents the limits of my viewport. It's basically the exact same information. If I go to the block properties, you can see the layer that it's on. You can see that I've named it the plan view shape. It serves the exact same function as what our named viewports do, but it works in conjunction with these CTC Sheet Generator tool sets. And then a profile view shape. So it's two different blocks, one representing the plan viewport scale, one representing the profile viewport scale, and overall dimensions. And that's all I need to do for my kind of sheet template for Civil 3D to understand it. The only other thing that I've set up in here in kind of predating or preparing for this meeting was I do have a match line block. And I'm going to insert that into here really quick for you to see. I'm just going to accept the defaults here. But the match line block is just a single polyline with some attributes assigned to it. And we're going to get prompted for those attributes whenever we place this match line as part of the tool. So just like in Civil 3D's plan production tools, where we have to have a lot of templates set up, we have just a little bit of setup to use the Sim Project Suite's Sheet Generator tool. And this allows us to better accommodate our match line labels, which Between you and I don't particularly like the match line settings out of the box. And this actually mirrors more of what I'm used to seeing on a set of plans. But that said, we've just got a few different attributes and a flip state for that match line. I'm going to discard the changes because I've really changed nothing. And I'm going to delete this instance of the block, but the definition is still a part of my drawing. And I'm ready to go. As long as I have those three blocks defined, the plan block, the profile block that represents the viewport size. I don't even have to set the scale. I don't have to set the units. I just have to have the size. And then as long as I've got a match line block that represents what my match line itself is going to look like, I'm in good shape. All right, so from the Sim Project Suite on the sheet generator, I can go to Plan View Shapes. This is very, very similar to what we do with the Viewframe Groups straight out of the box from Civil 3D. We define our alignment. We define our start and end station. We define our scale. That's the one aspect that we don't set. Normally, we would pick a template out, and that template would have the defined scales. Here, we get to define our own scale, and it's just going to use the dimensions of the plan view shape to define what actually fits in there. So a 20-foot scale for our sheets to be created. The print area, it's going to be centered using the print area block. Again, there's that plan view shape. That's a block that I defined as part of this drawing before going through the process. Would I do that on every project? No, I would do that once on my template, and I would not have to worry about it ever again. And then whatever layer this print area block is going to land on. I'm using more of a generic information. Michelle, thanks for reaching out saying, is this being recorded? Yes, it is in fact being recorded. A link to that recording is going to be pushed out to our social media pages and via whoever's an email subscriber to ATG's information. It'll be available on YouTube, usually within a couple days after the webinar is finished. Thanks for the question on that. But back to the topic at hand, the print area block layer is literally what it's going to be produced on. It's what it was already set on. I keep that consistent. It's just a generic G layer for annotation viewport. Go to next. What's the distance between match lines? We have a maximum distance that's defined, again, based on the scale that we set in the previous page of the dialog that correlates to the actual size of the viewport plan shape. That block that was defined. It, as a maximum at 20 scale, can fit 506.67 feet. I'm going to say either 300 or I'll go ahead and stick to the 350 feet of distance between match lines. That should give me a general even distribution over the length of this alignment. Again, I'm acknowledging that it's a fairly short alignment, but the process would be the same if there was 100 pages versus a few pages. We would define the maximum length. Generally, you're probably going to select a distance that is at an even station value, so that whenever your sheets are cut and you're rounding to a nearest station, that you have a nice even station value for your match lines and your sheet separation from one to the next. We can choose to avoid alignment vertices, so that if we have 2 points that come in, at an angle, it's not going to try to shove a view shape in at a weird angle or corner of that alignment. So unlike Civil 3D, that'll just throw in a view frame wherever it can fit it and average those distances, we can actually shift our sheets a little bit using this tool right out of the box, or rather right out of the tool set, and allow it to avoid those awkward locations within our alignment. I do want to clip the views at my match line. That's something that Civil 3D uses a hatch pattern to generally to imitate clipping those views. But we can actually clip the view itself and eliminate that additional information beyond the match line that's going to be shown. What's the view shape layer? Again, this is kind of pointing back to the information that we already set. I put this all on that generic annotation viewport layer. And whether or not I insert some drafting guides, those drafting guides give me a limit to where I can actually fit things on my sheet. So we're going to see two different shapes that drop into our drawing whenever I hit finish. Those shapes are going to represent the overall view shape that represents what fits on a plan view. And then we're going to get a smaller drafting guide shape that actually is trimmed down to where our match lines are. That'll show us what fits on a sheet. And if you label outside of this, it's not going to show up. So I'll click finish. And I've got a few view shapes there. 1, 2, 3. Again, my start station's down here at the bottom. Much like the Civil 3D Viewframe group, these are editable, but I can just use my regular old AutoCAD commands to edit these view shapes. I don't have to use those 3 limited grips of moving it, rotating it arbitrarily, because we don't really have good rotational controls or parametric constraints with it. I can just use, well, and I don't want to select my viewport or my X reference there, but I can select my view shape, and then there's that drafting, sorry, here's my drafting shape, my drafting guides. Anything that's beyond that polyline will not show up in this first sheet, but there's my overall view shape. So I can select both of those, and I can just use a regular old AutoCAD rotate command and rotate it about my starting station and use a rotate associate. And I can come back through and I can make those adjustments again with the next view shape and its associated information. I can go back to its match line point with the subsequent sheet, and I'll do a reference rotate again to where it's perfectly north-south. And I just have better controls over this than I do with the out-of-the-box tools. It's not that the out-of-the-box tools are bad. I just prefer having a little bit more control over it. And we're all familiar with AutoCAD functions. So there's my match line. I can adjust. Again, these are effectively, these are just polylines that represent the information that we want to trim. I can add and remove vertices. Those vertices can be manipulated and additional vertices created to more accurately represent where all of these intersections are taking place. And they don't have to be rectangular shapes. All right, that may not have been perfect, but for the sake of time, I think I've got that representing what it needs to. Yep, here's another one where because of the rotation it was at before, not quite perfect. I don't want to get too caught up with the weeds here, but again, we're just using regular old AutoCAD edits to polyline shapes. So those are effectively my CTC Sim Project Suite plan view shapes. What about my profile views? Well, I already have a profile view here, but one of the downsides to me with the out-of-the-box tools is when we cut those individual profile views, we don't see them until we open up those sheets. We don't see what lands in each profile view until we finish the process and view those layouts and see what actually lands inside the viewports. We can actually create new profile views for what's going to fit on those sheets. This looks very similar to creating a viewport or a profile view with the out-of-the-box tools. But you'll see as we jump through this, there's a couple other, little intricate details inside this create multiple profile views dialog. I'm going to change the style to our 20-foot and 5-foot increment profile view. I want my length of each view to match what my plan view lengths were, 350 feet. If I mess this up, I can go back and reproduce these after the fact. It's going to regenerate all my profile views, update my profile view shapes, and so on. But if I set it up now and it matches my my stationing ranges of my plan views, my profile views are going to look exactly the way that I want them to on my sheets that are going to be produced. So again, just a couple additional things. This is going to change my view height considerably compared to what I want. We can change to minimum and mean elevations and set what that elevation range would be. Automatic, because I've only got an existing and proposed profile that's going to be included in here, would be a very, very short profile, maybe only 5 or 10 feet tall. But I'll change to user specified and say I want a 40-foot tall view for my profiles that averages the mean elevation of my contents that are going inside of it. We'll go to next. What kind of labels? Again, this is not entirely different than what we're used to out of the box with creating profile views, but I do not want to use a profile label set. And it looks like I forgot to enable a no display or no label option in here. So I'm going to end up having some labels to delete. But I've got my proposed layout grade and my existing grade that I'm cutting sheets for. Do I want my storm and my sanitary network in here? Maybe I do. Maybe I need to create it after the fact. I'm going to leave those blank for now. Define what my existing and proposed grade elevations are for my data band, and go ahead and determine how I'm going to lay out these views. By default, these are going to be laid out by row. That's what I like to see, so I can kind of see the progression of the profile views. Other folks who use this tool like to do it by column and see them all stacked. But I'll go ahead and create views, pick a point in space, and we'll see those views ultimately created. Just a second for Civil 3D to catch up. And there's my views. There's that extraneous existing labeling that I didn't want to see, again, because I didn't give myself a no label option for existing grade lines. That's on me. And the thing that I'm lacking in these views thus far is my networks. So I actually have a networks to views option that does a great job of extracting the shapes and placing them in each of these views. And the benefit of this over the out-of-the-box tools is that it actually speeds up your ability to open, regen, and close those drawings that these are projected into. It handles it in a different way that is not so data dependent, that you have to wait for the entire network to load and things of that nature. So I can add networks to views. I can define those views. I could put a rectangle selection around them, or if I didn't have the additional view down at the bottom, I could have hit all. And I can determine the maximum horizontal distance from those parts. Most of the time, we have networks that we want to see in views that are parallel to our alignment. Whenever we've got perpendicular parts that are projected out, we don't necessarily want to see those parts drawn in our profile view. So we're given just a generic prompt of how far does a part have to be away from an alignment before you don't want to see it projected into our profile view. And I generally use a setting of 25, but every project may be a little bit different. So I'm not having to select my profile parts. I just defined an offset limit or tolerance, and it projected those parts into my profile views. Have I labeled them yet? No, that's for a different webinar. I want to be respectful of your time in utilizing these tools. So I've got my plan view shapes. I've got my profile views created, but just like I have plan view shapes, we take this to another step and are given the opportunity to create profile view shapes. This is very similar to that second step in the process of creating sheets using the out-of-the-box tools, where we have to tell Civil 3D how to associate the plan and the profile view in relationship to each other, and what their offsets and alignment is going to be. So if I create profile view shapes, again, I can select which profile views I'm creating shapes for, define which alignment that they're associated to. Again, what plan print area block, it represents the view shape and the layer that's according to that. Generally, I'm using this top option, this top radio button, because I want my profile view to align with my alignment. I want the stations to be in relationship to each other, but we can center the view or offset the view up or down, or sorry, left or right. And then we have some additional controls for the view shapes that are going to be inserted, representing the viewport, what the viewport's going to capture, with some positioning changes. I have found, based on my viewport style and my use of a data band and how tall my data band is, that I need to consistently set a Y offset of -30 for this to work for me. It might be different for you, but I know that that's a consistent setting that I need to shift my view frame shape to capture my station and my EG/FG data band information. But I'll go to next. Again, relate to now my profile view shape layer and block layer, and then the actual profile view shape itself. This is looking for that layout information, that profile view shape block, and what I named it. If we needed it to be at a different scale than our plan view, we could set it. I'm not a big fan of that. I don't know many jurisdictions that put their profile views at a different scale than their plans when they're on the same sheet together. But again, I didn't have to create a bunch of different layout templates set at a million different scales for my projects. I get to define that scale here, and Civil 3D is going to align everything within that view shape. And if you have that buffer space that we otherwise could have set between the sheets, the overlaps, we don't necessarily want to see an overlap of our profile data from one object to the next, to where now we're kind of seeing duplicate pipes or duplicate structures. So if you did use a buffer setting previously for some overlap between sheets, we do have the option of creating just a simple block. Maybe that block is just a rectangular block that would be expanded and used as a masking. And it would not hide the grid, but it would hide all of the data that we don't want to see overlapped between those sheets. Because again, we're using the plan information to determine our profile limits. And if we had an overlap in our plan view, we would ultimately end up with an overlap in our profile view, and we don't necessarily want to see those parts 2 different times. So that masking block could be beneficial there. I happen to not use the buffer, to not use an overlap between the sheets, so I don't need a masking, but that option is available to you. You could set up another block there. It's just a rectangular block that nothing special about it, that you're setting on a layer, and Civil 3D is going to mask that overlapping data for you using these sheet production tools. But I'll choose finish. You can see again, there's those view frames that came in. They came in exactly how I wanted them to. The reason why I wanted them to be produced that way. And actually, I do need to make a quick change because I realized whenever I produce these sheets, I set it to a mean elevation rather than a defined elevation. So I'm at 802 to 842 instead of 800 to 840 like I'd probably like to. I could go through and move profiles. I could go through and adjust the profile information, or there's still Civil 3D profile views. I can still use the regular out-of-the-box tools to make these changes. So just because we're using the sim tools does not mean that you're limited to the sim tools. It doesn't change the inherent data that we're working with and its Civil 3D properties. So that's the nice thing that I think some people are pleasantly surprised from, is if we're using these tools, you're not breaking anything out of the box. We're just supplementing it and providing you that opportunity to make adjustments after the fact. And these view shapes are dynamically tied to the sheets that they're ultimately connected with. So I've got plan views, I've got profile views. I'm actually ready to create my layouts. Drawing, it has unsaved changes. Sure, I'd like to save it. I also know I'm going to get another error here because I'm not using data shortcuts and references in this particular drawing because it's a sample data set, because I kind of did everything in one drawing to keep it self-contained for training. I'm going to get a warning because it's going to duplicate this information in the subsequent sheets. Best practice would deem that whenever you're cutting your sheets using data referenced model information, so that whenever the sheets are cut, it's utilizing those same data references in those sheets rather than duplicating the data. So acknowledging my negligence there and what the better practice would be, but I am in fact creating a plan and profile sheet. It's carrying over all the information that we previously defined. I don't have to change any of that. It's the same information that we set up before. It's giving me the view shape station ranges. Again, it doesn't mean that I'm starting at -85 plus 1.5. That's just the limit of our view frame because of the overlap that I defined and how it's centering things up. I don't even have a station -85.15. That's just the relative distance from 0 plus 0, 0 that the view shape is capturing as part of the viewport. So keep that in mind. We actually have good station ranges. I didn't take the time to adjust my match line to an even station between the first and second view frame. So that's an adjustment that I would otherwise make, but I'll go to next. Confirm the north arrow block that's in the drawing, confirm the match line block that I talked about previously that has that attribute information, and I can map that attribute information to what this prompt is asking me for how it's going to flip based on it being on the left side or the right side of the view, what the attribute for the previous or the next sheet is going to be, and what the station value is where that match line is ultimately placed. Again, using some really rudimentary AutoCAD tools to accomplish this. It's attributes within a block, and the CTC tools are just updating and adding in those attribute information for us once we have this mapped. Again, much like Civil 3D, we're template dependent on things. And the nice thing about the sheet generator is after you go through this the first time, it saves those settings. It looks for those same objects to where you're not redefining this every time. So I will not insert a match line for my profiles. That's just not something I typically do, especially because our profiles typically start and end at a major station value that's captured in our data band labels. Next, layout to duplicate. That's the layout that I have in my drawing, rather than I could have picked another drawing elsewhere. My naming template for what that's going to be called. I only want to create one layout per drawing, so I'm going to end up with 3 drawings, just like I did using the Civil 3D out-of-the-box tools. And the viewport scale, again, confirming that my plan, my profile, and the sheets that are going to be created are all using a 20-foot scale. What is the new drawing file name going to be? And what sheet set template or sheet set file am I connecting them to? Hit finish. Going to produce those sheets in the background. Takes about the exact same amount of time that Civil 3D uses the out-of-the-box tools to produce their own sheets with. But the big payoff, the big benefit is, unfortunately, what we may not have enough time for, is making changes to the view shapes themselves in our drawing, and then updating the layouts without recreating the sheets. Give it just a second to produce those last view shapes and layouts. Michael, you've mentioned twice within the chat something about units. Could you expand on that comment? And I'll try to get back to you here in a moment. If you're, I'm in Imperial Units for this, and everything's at a 1 inch equals 20-foot scale with the things that I'm working on. But if you could expand on that comment, I'd be more than happy to address it. Okay, so the sheets have been created. If I look at my group, I've got the 3 sheets that were created through the out-of-the-box tools. And then I have the 3 sheets that were just created using the Sim Project Suite Sheet Generator. So if I open up the first drawing, again, I need to change this data set to get rid of that custom line type. Shame on me. Here's the one thing that I like more than anything else about this tool, is that this match line looks the way I want my match lines to look on a set of plans. More so than what the out-of-the-box tools do. It's not masking everything in the viewport over here. It's literally clipping the view to negate the things that I don't want to see. And because my G annotation view frame or viewport layer is no plot, I don't have to worry about these blue or these cyan lines showing up in my plot either. So we don't have a previous sheet for that first sheet. So that's just a match line label that gets to go away completely. We see our north arrow is still rotated using the Sim Project Suite tools. And actually, I really like how my viewports look using this tool far and above how the out-of-the-box profile generation happens using the Viewframe Groups. We have to do a lot more tinkering with our viewport scale, viewport size, our profile view styles to get everything to match up just so, using the out-of-the-box information without having to do a lot of editing beyond. And even then, you saw previously, there were some view settings that I had to manipulate just to see the correct information in the profile view that was created in these individual sheets. So we've got the same relationship. If we've got fields and attributes in our title block, it really is working the exact same way as the out-of-the-box tools. That little bit of extra setup that we do and the little bit of familiarity that we have to gain from learning the Sim Project Suite goes a long way to the productivity gain. And that's the last thing I wanted to happen at the end of a session, was a fatal error. But I suppose that's just a signal that I needed to stop the demonstration and answer the question that came across the chat. I would like to see again a civil tool that when creating the plan and profile sheets, I would not have to cut the profile into multiple parts. rather insert the profile as it was originally, and then the tool creates the viewports and generates label frames to label the elevations of the profile. Okay, basically what Softdesk and Land Development Desktop did before Civil 3D. Thanks, Jorge, for that question. Technically speaking, you could accomplish what you're going for there, but it would require some editing in the plan view, in the paper space view. You'd have to develop a paper space line work and labeling in the paper space view, or use a table style with maybe some fields inserted into it that correlated between the model space information that's either X referenced or data referenced in for the profile grade line and labels and whatnot in the model view through the viewport, and then paper space information that kind of correlated on top of that. That's about the only thing that I've seen somebody creatively do to use one continuous, contiguous profile while bringing that same information into their disparate sheets. If not for that, which admittedly requires some manual editing and ensuring that you've not made any human errors between the datum elevation of your profile versus what you actually have shown in the paper space views, which is why I'm not a particular fan of that method. But that's about the only way I've seen anybody successfully use a continuous profile view through all layouts without chopping it up into its individual pieces. I do like the CTC Sheet Generator tool and how it produces the sheets or each profile view for the subsequent sheets, because at least we see them all in one model space environment and we can determine the connectivity between everything. We see that continuous flow without having to jump from sheet to sheet to sheet, or to that new drawing that was generated from the sheet creation tools. See here, I certainly did not want to end on a bad note with a fatal error. That was the first time I've seen that in several weeks, and maybe that's to my benefit within Civil 3D, but that just signals that it was time to finish up. Please, if you've got any further questions, throw those in the chat in the next couple minutes, but I'd love for you to connect with us at ATG on LinkedIn or via our YouTube channel, as I mentioned earlier, via Michelle's question. These videos from our webinars are all recorded and generally posted to our YouTube channel within a day or two, maybe every once in a while, a few days after the webinar is complete, depending on the length of the webinar and the complexity of editing that needs to be done at the beginning and end of it, or if there's any technical issues. So bear with us while that gets posted, but connect to our YouTube channel, follow it. Follow us on LinkedIn. We share updates regularly on when this free content is made publicly available to everybody as a recording, in addition to our white papers and blog posts that we provide, again, free to all those who are just looking to get a leg up on their skill set. And then if you want to, I'd invite you to please follow me on LinkedIn as well. I share that content, love to connect with you, talk offline about some of the issues that you've had. Maybe you've got an idea for another way to use these tools, or you had a question that didn't get answered during this session. Feel free to reach out. I'd be more than happy to chat with you about it, or at least refer you to the correct resource. So I appreciate your time. I appreciate you joining us either today or later when reviewing the recording on YouTube, and I wish you the best. But seeing that no further questions have come through the chat or the Q&A session, I'm going to go ahead and end the meeting. Thanks again for your time. Have a great day, and hopefully nobody fools you on this April 1st.